Today we are going to learn about standard form and x and y intercepts. So let's take a look at our goals for today. First, to identify which functions are linear. Second, to write equations in standard form. And then finally, to use standard form to identify and graph the intercepts. So what is a linear equation? First and foremost, a linear equation has no variables with exponents other than 1. So that means no exponents like x squared or perhaps the square root of x. A linear equation also has no variables in the denominator. Third, a linear equation has no variables that are multiplied together, such as x times x or x times y. And finally, a linear equation always represents a straight line. The general standard form of a linear equation is ax plus by is equal to c, where a, b, and c cannot be fractions, they cannot be decimals, and also the leading coefficient, which is a, because it's in the front of the problem, the first coefficient that you see, must be positive. So let's decide whether these functions are linear. Our first function, y equals 2x minus 5, has a variable x with an exponent of 1, so that is okay, has no variables in the denominator or being multiplied together. So yes, this is a linear function. How about number 2? Well, in number 2, we can see that we have an exponent raised to the third power. So that's an exponent that's higher than or other than 1, so that means no, this is not a linear function. For number 3, again, we have an exponent that's only raised to the first power. We don't have any other variables multiplied together or variables in the denominator, so this is a linear function. And finally, in number 4, right from the get-go, we can see that we have a variable in the denominator. Because this variable is in the denominator, this is not a linear function. Now let's rearrange some of these equations to put them in standard form. First of all, our general standard form is ax plus by, which is equal to c. So what is wrong with number 5? Well, first of all, the leading coefficient, a, cannot be negative. So we have the x, the y, and the constant on the right, which is fine, but that leading coefficient cannot be negative. So I'm going to take my original equation and multiply it by -1. Multiplying by -1 makes my leading coefficient positive and changes the sign of every other term. So now a is positive 7, b is positive 5, and c is -35, and that equation is now in standard form. How about number 6? Well, number 6, first of all, is out of order, so I'm going to rearrange a little bit. My coefficient attached to the x needs to come first, so that will be minus 3/4 x. Since the 2/3 y is positive, it'll stay as a plus 2/3 y. And the 1/6 is the constant, so it needs to be moved to the right-hand side. So I'm going to subtract 1/6, and that's why the 1/6 is negative on the right. So, are we done? Well, not quite, because in standard form we cannot have fractions. So we are going to need to multiply by the least common multiple in order to get rid of our fraction. So our least common multiple is going to actually be -12. Multiplying by -12 will, first of all, get rid of our fraction in the denominator, as well as make the coefficient of the first term positive. So -12 times -3 will be positive 36x over 4. -12 times positive 2 is -24 over 3y. And -12 times positive 1 is positive 12 over 6. Now we can easily divide our denominators, and we are left with 9x minus 8y, which is equal to positive 2. So then our coefficients and our constant term, a is 9, b is -8, and c is positive 2. Now let's talk about intercepts. The x-intercept is the point at which the graph crosses the x-axis. An example of an x-intercept would be the point where it crosses the x-axis, so the value at the x-coordinate, which in this case an example is -4, and the y-coordinate is 0. So that means when we're solving for the x-intercept that we can plug in 0 for y, and whatever we get for x will be our x-intercept. The y-intercept is the point at which the graph touches the y-axis. So an example of a y-intercept might look something like 0, 7. Notice that the y value will be the y-intercept here, and in x we have 0. So that means when we're solving for the y-intercept that we are going to plug in 0 for x. So let's find the x and y intercepts and then graph this function. So in order to find the x and y intercepts, the first thing I'm going to do for the x-intercept is I'm going to plug in 0 for y and then solve for x, because my y is always 0 in my x-intercept. So I take my original equation and I'm plugging in 0 for y, so substituting in a 0 where the y is, and the rest stays the same. Well, 5 times 0 is 0, which is equal to 15x minus 90. I need to now isolate the x, so I'm going to add 90 to both sides. So I have 90 is equal to 15x. Divide by 15, and x is equal to positive 6. Next, I'm going to write this as a point because my x-intercept is a point on the graph. So since I solved for x, 6 goes in the x-coordinate position, as you can see, and then since I originally plugged in 0 for y, that is my y-coordinate. Now I'm going to solve for the y-intercept. In order to solve for the y-intercept, I'm going to plug in 0 for x, then solve for y. So in my equation, 5y is equal to 15 times 0 minus 90. Well, 15 times 0 is 0, so I'm left with minus 90. Now I can just divide by positive 5, so y is equal to negative 18. Now I can write this y-intercept as a point. Since I plugged in 0 for x, x goes in the 0 coordinate spot, and since I solved for y and got negative 18, that is in the y coordinate spot. So now let's graph this. I'm going to count by 2's in order to fit everything on the graph. And I'm going to first graph my x-intercept, which is over 6 up 0, which is just over 6 spots, 2, 4, 6, and then up nothing. And then graph my y-intercept, which is at 0, negative 18, so that is moving nothing left or right and then going down to negative 18. Finally, I can connect my points to form a straight line extending forever in both directions, and that is my graph. Let's do one more example where I solve for my intercepts. The first thing I'm going to do is plug in 0 for y and solve for x in order to get my x-intercept. So negative 0.08, x is equal to 1.24 times 0 minus 3.12. As I'm moving along, 1.24 times 0 is 0, so I'm just left with a minus 3.12 on the right-hand side. I can divide by negative 0.08, and x is equal to 39. So my x-intercept will be 39, 0. Now for my y-intercept, I'm going to plug in 0 for x and then solve for y. So negative 0.08 times 0 is equal to 1.24y minus 3.12. Negative 0.08 times 0 is 0, so I have 0 on the left-hand side. I'll need to move my constant of 3.12 over to the left, so I have positive 3.12, which is equal to 1.24y. Divide by 1.24 on both sides, and I'm left with y is equal to 2.52. So since we are graphing, it is appropriate to leave this intercept as a decimal form, especially since our original equation was in decimals. So now I can write this as a point at 0, 2.52. So since my x-intercept is such a high value, I'm going to count by fives on my graph to fit everything in. And now I'm going to graph my x-intercept at 39, 0. So I go over 39, up 0. And I'll graph my y-intercept, which is 0, 2.52. So over 0, up 2.52. Now I can connect those two dots from left to right, and I form my line of the graph. Now it's your turn to try the two problems below. So go ahead and try those two problems and make sure that you come in with lots of questions tomorrow so we can answer those questions and then work on some practice problems.